Mankind has always sought simple solutions with marvelous tools, and these inventions are proof of that, so stay tuned to appreciate them. Safety at railroad crossings is crucial. Stopping when the barriers are down could mean the difference between life and death. Enfill, a Belgian company dedicated to maintaining and modernizing the Belgian railway network, one of the busiest in Europe, conducted a shocking crash test that'll leave you speechless to illustrate this reality. Accidents at level crossings occur almost weekly in Belgium, so Enkenbel felt the urgent need to show drivers the devastating consequences that can arise from this common mistake. In this incredible crash test that will amaze you, a collision between a car and a train was simulated. The impact was disastrous. The people inside the car experienced a force of 63 G. To put this in perspective, a trained F-16 pilot can withstand up to 9 G before losing consciousness. This disparity reveals the tremendous violence of the impact at a train crossing, where the mass and speed of the train make any collision extremely dangerous for the car's occupants. Calculating the probability of survival in such circumstances is heartbreaking. The force of 63 G exerted on the human body can be fatal in most cases. Although modern vehicles are designed with advanced safety systems, including airbags and seatbelts, the kinetic energy involved in a collision with a train is overwhelming and often insurmountable. If this feat intrigues you, the next one will leave you speechless. A NASA research center, with its modern crash test facility, represents the forefront of aviation safety. This center is essential for conducting rigorous and controlled experiments that provide crucial data to improve flight safety. Among the many projects they carry out, one of the most important is the testing of the durability and behavior of small planes like the Cessna 172. In one of these tests, the Cessna was dropped from a height of 25 meters, simulating an emergency situation where the plane loses control and plummets. But the research doesn't stop with small planes. The center also tests larger passenger planes like the Fokker F-28, a regional jet with a capacity of 85 people. These tests are extremely meticulous and detailed, as they seek to recreate a wide variety of possible scenarios in an air crash. During a typical test, dozens of cameras are installed inside and outside the plane, along with 24 mannequins equipped with sensors in the plane. These mannequins are designed to replicate human physical characteristics and responses, providing valuable data on how people might be injured in different types of collisions. The tests at this facility are crucial for understanding and improving aviation safety. The data collected helps engineers and scientists create accurate computer models of safer aircraft cabins. Did you love it? This next invention will blow your mind. Nordic Road Safety has been tirelessly dedicated to improving road safety for more than 3 decades. These devices are not only designed to keep vehicles on the road, but also to prevent trucks and buses from veering off or overturning, which is crucial for protecting both drivers and passengers. In addition to their protective function, these devices also significantly contribute to the stability and structural integrity of bridges, ensuring that critical infrastructures can withstand heavy loads and adverse weather conditions with maximum safety. Sometimes they lie, but this product was and is a marvel in everything it does, and the next one completely redefines technology. The Tesla Cybertruck, although not designed as an armored vehicle, offers remarkable protection against small arms fire. During tests, the vehicle withstood shots from a Glock pistol using 9x19mm parabellum rounds and a Thompson submachine gun with 45 ACP cartridges. Despite the impacts, the bullets only left dents on the body without penetrating it. This resistance capability is largely due to the use of more robust materials compared to conventional cars. For instance, the panels of the Tesla Cybertruck's doors have a substantial thickness of 3mm and are made of stainless steel, known for its superior strength. This choice not only increases protection against external damage, but also reinforces the vehicle's structure, providing additional defense in potentially dangerous situations. This innovation not only underscores Tesla's commitment to user safety, but also sets a higher standard for the resistance and durability of next-generation electric vehicles. What exactly happened? The HMCS Annapolis, a ship that faithfully served in the Canadian Navy for decades, has reached the end of its useful life. Instead of being scrapped, it was given a new mission: to become an underwater refuge for marine life. Transforming the Annapolis into an artificial reef was no simple task. It involved years of planning, preparation, and collaboration between multiple organizations and government agencies. Before its sinking, the ship was meticulously dismantled and cleaned to ensure that no toxic or hazardous materials remained that could harm the delicate marine environment. On the day of the sinking, the event was carefully documented. 19 cameras were strategically placed around the ship to capture every angle of the process. These images not only served to document the historic event, but also provided valuable visual data for scientists and conservationists. And if that intrigued you, let's move on to this product, which is a masterclass in how fascinating crash tests should be executed. And children deserve maximum safety in their daily transportation. That's why school buses are regularly subjected to rigorous crash tests. These tests not only verify the structural integrity of the bus in the event of an accident, but also examine details that can be crucial for children's safety. One aspect evaluated is the configuration of the dog notes, small safety devices that ensure the bus doors remain closed during the trip. Although it may seem like a minor detail, these devices are essential to prevent children from falling out of the bus while it is moving. Crash test videos show the effectiveness of these mechanisms, keeping the doors firmly closed even in extreme situations. In addition to structural integrity and mechanical safety, every aspect of the school bus design is carefully analyzed. For example, the design and padding of the seats are tested to ensure they can absorb the impact of a crash, protecting children from serious injuries. Seatbelts in buses that have them installed are also rigorously tested to ensure they keep children in their seats during an accident. If this one fascinated you, the next one will undoubtedly. Having the possibility to drive a Bugatti Chiron at a dizzying speed of 420 kilometers per hour is an experience that combines luxury, speed, and cutting-edge technology. However, this ride comes at a price in terms of fuel consumption. The Chiron's 100-liter tank will run out in about 9 minutes at that top speed. This impressive performance is a testament to the advanced engineering of the French manufacturer, which has implemented significant innovations to achieve such figures. One of the most notable innovations in the Bugatti Chiron is the manufacturing of its brake calipers through 3D printing, a first in the automotive industry. Bugatti chose titanium as the material due to its high reliability and strength. Titanium is not only lightweight, but also offers excellent resistance to heat and deformation under high loads, which is crucial for a high-performance vehicle like the Chiron. These titanium brake calipers allow the Chiron to stop from 100 kilometers per hour to 0 in just 2.5 seconds, an impressive feat that underscores the vehicle's control and safety capabilities. During tests, these calipers proved capable of withstanding extreme temperatures, reaching up to 1,000 degrees Celsius without losing their structural integrity. This level of durability is essential for a car that can reach and maintain such high speeds, where the braking system must handle a tremendous amount of kinetic energy and heat without failing. We continue with this beautiful device that exceeds expectations and becomes the ideal robot that we could only see in a futuristic world. Braun Industries stands out in the field of vehicle safety, especially when it comes to their ambulances. Their commitment to safety goes far beyond standard norms. In 2016, the Braun team conducted a test that had never been done before. They analyzed the consequences of an ambulance rollover. This test was not just a simple rollover, it was meticulously planned and executed. They began with an ambulance that had already passed a side impact test, ensuring the vehicle met basic safety requirements. Using specialized equipment, they simulated a rollover by having the ambulance travel at a speed of more than 40 kilometers per hour. The vehicle's modular body, specifically designed to maintain its integrity during severe impacts, proved its effectiveness. Throughout the process, the test dummies equipped with sensors to measure forces and potential injuries remained safe inside the ambulance. The test didn't stop there. To further evaluate the vehicle's resilience, Braun Industries conducted a second phase of the test, a high-speed side collision. They used a Ford F-150 truck weighing more than 2 tons and crashed it into the side of the ambulance at approximately 64 kilometers per hour. This next invention will undoubtedly amaze you. Trek has developed an innovative anti-ram barrier that stands out for its strength and versatility against the most incredible crashes. This barrier is designed to stop extremely heavy vehicles up to 20 tons, traveling at speeds of up to 40 kilometers per hour. The ability to stop vehicles of this size and speed is crucial for protecting sensitive or high-security areas, such as government facilities, industrial sites, and high-traffic pedestrian zones. The structure of the Trek barrier is remarkably robust, capable of covering road sections ranging from 4 to 8 meters wide. This adaptability in size allows the barriers to be used in a wide variety of scenarios and locations, from narrow streets to wider avenues. Additionally, the flexibility in its installation and operation ensures they can meet the specific requirements of different environments and security needs. One of the most impressive aspects of the Trek anti-ram barrier is its dual control system, which includes both automatic and manual options. This dual design allows operators to choose the most appropriate control method for the situation. Under normal conditions, automatic controls may be sufficient for daily operation, providing efficient operation without the need for constant human intervention.